started. Our first speaker is Theodore Arabatsis. It's coming from National Antiquarian University of Athens.
Thanks. It's getting worse and worse. It's hard enough to pronounce my name, but pronouncing the name of the university. Well, I want to thank the organizers for giving me the opportunity to be here on a great occasion. I have mixed feelings about it, I have to say, because you took away studies from us. But it was a great choice. I will miss him, but I wish him all the best. Now, I was asked to talk about general philosophy of science, and the topic that I've been working on is the integration of history and philosophy of science. So what I want to do is talk about some possible ways of integrating history and philosophy of science, and look very briefly at the history of HPS and all the troubles and difficulties that one sees in this relationship. It has been a very stormy relationship, very difficult one, and I want to understand why. And I want to understand why the relationship was very troubling from a historian's point of view. Okay? Now, I think that there are two ways, at least two ways, of integrating history and philosophy of science, what I call historical philosophy of science and what I call philosophical history of science. So in historical philosophy of science, the aim of the enterprise is philosophical. So we raise philosophical questions and issues, and we draw upon the historical information to come to terms with these issues. Okay? So that's one possibility. In philosophical history of science, the aim is very different. To draw upon philosophy of science to tell better stories about what happened in the past. Okay? So these are very different things. And I think if we look at the history of HPS, the history of HPS is dominated by historical philosophy of science. There is very little philosophical history of science. Okay? Historians haven't been all that interested in philosophy of science and ipso facto in philosophical history of science. So let's go very briefly over HPS in historical perspective. I'm sure you are familiar with the so-called marriage of HPS in the 1970s. The discussion began with the publication of a collection edited by Roger Stuart, a very well-known historian of physics, and the review of that publication by Ron Geary. Okay. Now Geary complained that there was, he said that there was good philosophy of science in that volume, good history of science in that volume, but not real integration between the historical and the philosophical dimension, and raised a very important challenge for historical philosophy of science. How can norms, what do norms have to do with facts? Okay, philosophy of science is a normative discipline, supposedly. History of science is a descriptive discipline. So how can we bring both disciplines together? Geary's answer was that we cannot. It's just a matter of convenience. Both disciplines are unhappy with their parents' discipline. Parent disciplines, they want to get away from parental home. That's about it. Okay, there's nothing more to that. Now, other philosophers thought otherwise. Ernest McMullen, Dick Burian, and they suggested various ways in which history of science is important to philosophy of science. But as you can see, the focus of the discussion is on historical philosophy of science, on the importance or non-importance of history of science for philosophy of science, not the other way around. Okay? These guys were not worried about the potential relevance of philosophy of science for history of science. The only two people that, from that period, that commented on the possible relevance of philosophy of science for history of science were Imre Lakatos and Larry Loudon. But at least Lakatos, did that in a way that was deeply troubling from a historian's point of view. Okay? Where he said that philosophy of science should be the starting point of historical investigation. It should raise the questions and it should circumscribe the area of investigation. And the real aim of the enterprise is not to tell accurately what happened, but to improve upon history, okay? To rewrite history in a way that would conform to, you know, Lakatos' philosophy of science. And of course, it's impossible. I mean, history is too complex for that. We can't fit history within any schema. So what's the solution? Well, you know, organize the text in two levels. On the top level, you know, you have philosophical reconstruction, and on the bottom level, you have all these inconvenient facts. Okay, so that wasn't, you know, I mean, if the point of that was to bring historians and philosophers of science together, that wasn't a very, very good idea. Okay, no wonder that historians were not all that interested in this. I won't go into Laura in the interest of time. Now, on the basis of Lakatos' methodology, that volume was published in 1976. The opening chapter is Lakatos' paper, History of Science and its Rational Reconstructions, and then there's a series of case studies. Most of them are very, very good case studies that break new historical ground. But I think that the reason, or not the reason, but one of the reasons perhaps that they were good case studies is that they did not follow Lakatos' advice. Okay, so you don't see that, you know, two-level organization, you know, with you know, the main text, which is fictitious, and then, you know, all the correct facts in the footnotes. So Hume reviewed that volume, and he said more or less what I just told you, that, you know, it's this volume, despite the fact that, you know, Lakatos' methodology is very problematic from a historian's point of view, but from another paper of his at the time, he was very dismissive about philosophy of science in general. Even though, you know, he stressed the importance of history of science for philosophy of science, he thought that philosophy of science, at least as it was practiced at the time, had no relevance to for the historian of science. And why was that? I think that the main reason for that was, again, that philosophy, in Hume's view, is a normative discipline, is interested in how science should be done, okay? And this isn't all that much interesting from a historian's point of view. I mean, Hume was, of course, a seminal figure, but he had symptoms of a split personality. I mean, he couldn't integrate, you know, his the philosophical aspects of his, you know, his thought and the historical aspects of his thought. And I think that that's not the right way to go. Now, in the 1980s, we had the, you know, the so-called VPI program by Loudon and his colleagues. And there, the point of the enterprise was to test in a very detailed way various theories of scientific change. And again, that program was not very well received by historians of science. You know, I can only speculate why, but you know, I will offer two reasons. The first is that, you know, in the VPI program, the role of historians of science is subsidiary. You know, they're just collecting facts. I mean, the action is you know, on the philosophical side, and the historians just do, you know, all the boring work. Okay. Well, why would anyone want to do that? And then, of course, for most historians, all these theories and the philosophical theories of scientific change and the test, well, they didn't believe in them anyway. I mean, I haven't met a historian who, you know, takes seriously Hume's periodization. Okay, normal science, crisis, revolution. Well, yeah, in some cases, perhaps one sees this pattern, but it's just a pattern among many. Okay, so what's the point of this enterprise? Okay, testing theories that we already know that are not true. And then, again, another area where history and philosophy of science were brought together was the realism debate after the publication of Loudon's paper. But again, that was, you know, HPS from a philosopher's point of view. Okay, historians were absent from these discussions. Now, one area in the 80s where history and philosophy of science were brought under the same roof, so to speak, was the history and philosophy of experiment. Okay, and starting with hacking. And hacking did something which was quite interesting. He revived the philosophy of experiment after more than 300 years. You know, you have Bacon, and then there's hacking, more or less. There is John Stuart Mill, Duane, saying a few things. That's about it. One of the scandals of 20th century philosophy of science, that we had to wait till the early 1980s to have a philosophical analysis of experimentation. And some of the ideas that Hacking put forward in that book were very influential among historians. So, for example, the idea that experiment has a life of its own, that experimentation is not reducible to theory, that the relationship between theory and experiment is very complex, and so on and so forth. I mean, these were themes that were taken up by Garrison, among others, in his book, How Experiments End. And here we see that the philosophy of experimentation provided motivation and heuristic guidance for historical work. And I think that the reason for this was that philosophy of science, in this particular case, opened up new areas of investigation, generated new questions that could be investigated empirically. Now, in the 1990s, if there ever was a marriage, the marriage came apart, almost officially. The two disciplines grew apart. I mean, the historians more or less stopped talking to philosophers of science. They turned to the sociologists of scientific knowledge, for better or for worse. And of course, philosophy of science also moved away from the issues posed by the historical philosophy of science. All these issues that had been discussed in the 1970s, the rationality of scientific change, became marginalized. At least that's my understanding. Now, let me come now to the possible prospects of HPS from the point of view of history of science. Okay, so integrate HPS qua philosophical history of science, and I put my own work under this framework. I think an interesting and pioneering work was Hasok Chang's Inventing Temperature, and there the idea is that one draws upon philosophical issues, as I said in the beginning, to tell better stories about what actually happened. Okay, so what exactly is measurement? How do we establish a measurement scale? How do we measure things beyond the area where our instruments function, and so on and so forth? These are philosophical issues, and Chang engages with those issues in telling the story of temperature, and I think he does a great job. And in my own work, I argued that there are various philosophical issues that are relevant to telling the story of the electron. And I will give you examples. So, in that capacity, I think the historiographical function, the historiographical role of philosophy of science is to provide a framework for understanding science and its past. Okay? That's our aim as philosophers of science, as I understand that aim. And if that's our aim, then this should be relevant. This should be relevant to what historians are doing. Okay? And I think that there's a great deal in philosophy of science that can be useful and interesting from a historian's point of view. Now, let me give two examples. The first is about discovery. When I was doing the historical work for the book, I was coming across the canonical story of the discovery of the electron, which I'm sure most of you know. Open physics textbook. Who discovered the electron? J.J. Thomson. When did that happen? In 1897. Okay, so you see that story repeated again and again, not just in physics textbooks, but also in the historical literature. Okay, and then at the time I was also thinking about the realism debate. So I asked myself, what exactly does that mean? Okay, so So yesterday, John said, well, you know, Thomson's electron has nothing to do with our electron. So what exactly did Thomson discover in 1897? Okay? So how can we identify, you know, the object of the discovery? So that's a tricky issue. So when we ask, you know, who discovered what and when, this is a very misleading question in a way. I mean, you have the impression that factual information is requested from you, okay? But then it's a question that cannot be very easily answered. So on top of empirical information, you need conceptual analysis to understand what is going on. Okay? So what I argue in the book is that if we engage with the realism debate, then we can tell a better story, we can give a better historical account of, you know, the discovery of the electron, but we have to reconceptualize it as an extended and complex process as opposed to an event. Okay? And then the other issue which also came up yesterday is about concepts. I mean, concepts evolve. So Thomson's concept of the electron and, let's say, Dirac's concept of the electron are very different animals. So why do they put them under, you know, the same roof? Why are they part of the same story? Okay. When I write a book about, you know, the electron, well, why should I include, you know, Thomson and Dirac? I mean, if they are talking about completely different things. So again, a philosophical issue is relevant to a historiographical question. How do we choose our historical subjects? Okay, that's so short, so I'm finishing. So I think that even though historical philosophy of science is not as central to philosophy of science as it was in the 60s and 70s, I think that historical philosophy of science is here to stay. Okay, very few philosophers of science, I think, would question nowadays the relevance of history of science, but that's not enough. Okay? So if we want HPS to flourish, also from you know, the historical side, we should reflect upon the reasons for, you know, historians in different philosophy of science. Why is it that historians of science haven't found philosophy of science very interesting or very useful, and make a case for the relevance of philosophical issues to historiographical practice? That was it.
Questions?
Yeah, so that was very nice, and I liked a lot of what you said, but you have this idea that philosophy of science could be used and useful to historians of science without falling into the Lactosh type of trap. And I wonder if you could say more about how that's going to work. Because, of course, the interesting scientists whose work we look at, whether they're from 2 decades ago or 200 years ago, tend to have philosophical assumptions and backgrounds, and that tends to be playing a role in the work. So historians need to know enough philosophy of science so that they can understand the subjects that they're actually working on. Just like they need to know calculus if they're looking at Newton and things like that. But if historians were to approach with a particular kind of philosophy of science in mind, wouldn't that be inevitably a distorting lens rather than a help?
No, that's a great question. I mean, I fully agree about, you know, the first part. Hopos, history of philosophy of science, is very important for history of science, because philosophy of science was very important to, you know, past scientific practice. I mean, we saw that in Aristotle. So philosophy of science, what we would call philosophy of science, or methodology of science, is very important for Newton and for many other scientists. So I mean, I think it's important when you do the history of these people to be sensitive and knowledgeable about, you know, the philosophical context. Okay, so I fully agree with that. Now, I wasn't talking about, you know, approaching the historical material with a particular philosophical perspective, but more with, you know, an awareness of the philosophical issues involved. Okay, perhaps at the end of the process, you will develop your, I mean, the historian or the philosophically inclined historian will develop his or her own philosophical position. Okay, so in my book, for example, I do that at the end, but in the process of coming to terms with the historical material. So I develop a philosophical account about conceptual change that I think, or I suggest, does justice to the complexity of the historical development. So a philosophical position, I mean, is unavoidable, but I think should come at the end of the analysis as opposed to the beginning.
So I think that one of the reasons for tension between philosophers of science and historians of science is a resistance to general explanations for history. And in the talk he talks about sort of general historiography, the ways we can make kind of generalities with respect to historiography. I was wondering whether you think that there's any prospect of kind of a rapprochement about the question of kind of generalities versus particularism in actual history.
Yeah, I mean, you are absolutely right that historians are very reluctant, to adopt overarching philosophical or general frameworks. But that's unavoidable. I mean, they do that when they use sociology of science, right? So the question to my mind is not whether we adopt a general framework, but whether the framework that we adopt can do justice to the historical situation that we are trying to describe. And this has to be argued on a case-by-case basis. Okay.
Thanks a lot. I wanted to ask essentially Carl's question, but maybe I could push it one step further. The idea that in reading historical narratives, confrontation model whereby we test philosophical hypotheses, right, might be problematic precisely because reading historical record with a philosophical thesis in mind, there's kind of theory latentness going on.
Sure.
So that was essentially Carl's point, I think. And now, my question is this, and you seem to be suggesting that we're not going to, in the kind of philosophical history of science that you're doing, we're not going to approach the historical record with a philosophical thesis in mind, but we're going to have an awareness of what the philosophical dialectics are, and that will allow us to grapple with it. So, I guess here's the further word. When you describe the historiographical role of philosophy of science as providing a framework, right, for understanding history. But if you are bringing to bear the philosophical dialectics, there isn't really a framework, right? There are a bunch of frameworks, because if you're inclined towards realism and you adopt something like the causal theory of records, you're going to read the historical records differently than if you have. If you're inclined towards certain forms of anti-realism, you have a more descriptive theory of records, and so on, right? You're going to actually describe the history differently unless you go for some very austere sort of micro-historical approach, which some people do, but historians of science don't want to, right? So then the worry comes back, right? You don't have a framework, you got lots of different frameworks, and inevitably, as you say, mucking around the details, you're going to settle on one of these frameworks, and then what I want to know is what is the status of that framework, since there are other possibilities.
Oh, okay. That's a very good, very tough question. Now, you start with an awareness of the problems, okay, the philosophical problems that are involved, even in the language that you are using, okay. And many historians, I have to say that, are not very sophisticated in this respect, okay. So when you read all this, talk about, X discovering Y, this dimension is completely absent, okay, and that's I think very harmful, or that prevents those people from doing justice to the complexity of the historical situation, okay. So that's the first part. But then you say, well, but if you are aware of the philosophical literature, you have your own philosophical views, right, or philosophical predilections. You may favor, the causal theory or the descriptive theory or whatever. And then if you approach the historical material with that framework in mind, that might be bad too. Okay. Well, I mean, my reaction to that would be, the proof is in the pudding. I mean, it depends on the quality of the story that you will be able to tell. Okay, so I mean, there's no general answer to the question. but it has to be argued on a case-by-case basis. So, for example, you see a historical fact that we have to come to terms with. That's something that we discussed with Richard. You see different scientists in different times using the same terms. Okay, so I mean, Dirac and I don't want to say Thomson, but perhaps Einstein or Lorentz, use the same term. Okay, we have to understand that. I mean, one may say, well, that's just a sociological fact. We don't really care. Just a contingent fact. These guys don't know what they're talking about. Well, that's the end of it. Well, I want a deeper account. What are the continuities? Okay, between Thomson's use of the term electron and, well, he didn't use the term electron for a long time, by the way. So, but anyway, after 1913, he started using the term electron. Before that, he used the term corpuscle. So, I want to be able to uncover, the epistemic reasons that led these people, to use the same terms over an extended period of time. Okay, so I want to give a philosophical account of that. Now, whether the descriptive theory or the causal theory would be better suited to this purpose, I mean, that's we can discuss about this. Okay, so I mean, my answer would be we have to look at particular cases and try to reach a reflective equilibrium between the philosophical position and the historical material, and I'm pretty sure that we can evaluate different stories. There are better and worse stories about what happened.
We have time for one more question, and then we'll let Jose speak, and then we'll have time at the very end. So those of you that are in the queue, I'll leave you to share.
So I'm nervous, worried about the temptation that we might have to sort of apply philosophy of science to historians as scientists, as themselves, sort of as collecting data and from deciding what counts as science and making these hypotheses about what the is that something we should be avoiding doing, or is that sort of part of this philosophical science?
I think we should avoid doing that. I mean, that's the older idea. I mean, Loudon's idea, the VBI program, we come up with theories about, how scientific theories change, second order theories about how scientific theories change, and then we test those theories against the historical record. There are, facts out there. That this doesn't work. Okay. So I think the, dialectics of, the interaction between, the philosophy and history of science describes much better, what I'm up to. Okay.
Okay. Well, first of all, I want to thank the organizers for the opportunity of being here, and since this conference is for welcoming studies and Cal, and I've been a fellow Cal in Barcelona for the last years. I want to take this opportunity to say that also on behalf of my colleagues there in Barcelona, that we are very happy for you, but very sad for us. You have been a great fellow, and we are very lucky to have you here, and we wish you the best. So, well, since this panel is on general philosophy of science, I've prepared a brief but very general presentation on something I've been interested on and working for the last years, with some examples that I won't enter into details. I have worked them out elsewhere. Actually, I will mention them very briefly, which is the distinction between guiding thoughts, what we call guiding principles and special laws, and try to show that it's a triple distinction. So the goal is to recall this Kuhnian distinction, further elaborated by Smithian structuralism, with this John Smith, and try to show its fruitfulness in different areas of philosophy of science, general, special, and history of philosophy of science. I will mention one example in each subfield without entering into the details, as I said. So what's the idea? The idea, I think the origin is in this beautiful Kuhnian passage, which reads as follows. Generalizations like Newton's second law are not so much generalizations as generalizations, sketches, or schemas, schematic forms whose detailed symbolic expression varies from one application to the next, a particular phenomenon. For the problem of fruitful, the generalization takes this form. For the simple pendulum, it becomes this formula. For couple harmonic oscillators, it becomes two equations, the first of which has this form. More interesting mechanical problems, for example, the motion of a gyroscope would display still greater disparity between the schematic form and the specific version from the particular phenomena to which it's applied. So, near structuralism, particular figure and Basel, Linus in the 24 science, elaborated this distinction with the idea of theory nets and the distinction between guiding principles and specialized laws. So the idea is the following. In highly unified theories, not all theory laws are at the same level. Laws come like with a hierarchy, with top laws which are very general and schematic, and bottom laws which become specific for particular phenomena. For instance, we take classical mechanics. We have at the top this what we call guiding principle. Tells you basically when you want to account for a change in motion, look for forces that added up just matches the change in motion. And then you have to look for very different kind of forces: space-dependent forces, velocity-dependent forces, directly space-dependent forces, inversely space-dependent forces. So you have here Hooke's law, a particular case of which is the law for Pelliot. So the idea is that this relation is not of reduction, but of a specialization or of a specification in which bottom laws specify or determine certain parameters left open above. And then we come out at the end with different bottom laws for particular different explananda. This is the idea. How can we make precise the Kuhnian idea? Sometimes I've been told that this is not very faithful to Kuhn. We can discuss that, but in any case, it was quite faithful for Kuhn himself, who recognizes in '77 and also in 2000 that this was pretty faithful to what he had in mind. So the structuralist factory has found the same schema in many different unified theories in thermodynamics, with a kind of general relation between entropy, energy, and some other parameters, which are specialized down in different forms. In natural selection, with a general principle telling that when you want to account for certain kind of trait evolution, look for the function that the trait allows to perform better with the trait and without, and a function which is beneficial for differential reproduction. So you have different kind of functions, survival, marking, fecundity, and different kind of survivals, sub-functions like food supply, escaping predators, like camouflaging, by running, etc. So it's pretty similar to, at least according to us, with what happened in mechanics. The same in Mendelian genetics, with the general law telling there is certain relation between phenotypes and genotypes, that genotypes are transmitted from parents to offspring, and there is a certain determinant relation between the way parents transmit offspring to transmit genotype form. In quantum mechanics, I have almost no idea about quantum mechanics, but my friends told me that the Schrödinger equation with the Hamiltonian here is like an open parameter that just can be determined in different ways for different phenomena, and many other cases. Okay, the important thing is that these top schematic principles, like Newton's second law, tell us very little. Just the kind of thing you have to look for, and a very schematic nomological connection between them. So the specific empirical constraint, empirical flesh, enters via these bottom laws. This is where the empiricity of the theory, without this makes almost no sense at all. This is the idea. This is why we used to call these top principles, guiding principles, which are empirically non-restricted. They cannot be tested in isolation, because in isolation they are most trivial. It's like if you take just the Ptolemaic guiding principle for a trajectory. Just try to build up a series of epicycles and differences fitting them. So you can fit everything, like Hanson claimed that a colleague of us in Argentina beautifully showing a computer program reconstructing Homer Simpson's face with a series of many thousands of epicycles in there. So the idea is that you have to fulfill the general principle with these specific laws, and specific bottom laws are where the empirical place comes. So the claim I want to make here is that this Kuhnian structuralist distinction and its associated net-like structure is relevant not only for knowing the structural theories, but it's also relevant, it may help in some specific, more interesting problems in special general history of philosophy of science. So this is the 3 examples I am going to mention in each field. First of all, general philosophy of science, in this case, the meaning, content of theoretical terms. I worked with it a long time ago. This is more or less a brief summary I published in a paper in 2002. So the idea is that the meaning of theoretical terms at least is partially constituted by the lawful connections with other terms. This is almost everybody agree on. The recent view tells us about the theoretical axioms, Kuhn's symbolic generalizations, Brinkman's paper and Penzian operation, etc. So the interesting question is which laws are constitutive of this theoretical part of the meaning of theoretical terms. So Lewis says all lawful connections at the time are constitutive. This raises a problem because these are too fine-grained individuation for a concept, because theories change. So we have not completely the same laws from the beginning to the end, and we want at least to capture a sense in which there is the same concept shared by Newton, Huygens, although maybe there is a different sense in which these concepts are different. It's an important sense in which the classical concept of mass is shared by all classical physicists. But then, as people say, if not all lawful connections matter, then the problem is which ones. If the lawful component is enough specific, then it cannot capture the same concept all along the whole history. But if it is not specific enough, then it's not sufficiently individuative, so we are not individuating anything. This is a problem which I think that the hierarchized net-like structure may have. Of course, for every particular theory, for the theoretical concepts of every particular theory, the specific meaning must be determined case by case. I mean, there is no way. But some general things can be said, and this is in the rest of which I think that the net-like structure may help. Because in principle, the net-like structure makes room for different way of different laws in the conceptual component of things. Of course, where to draw this line depends on as I said, in case-by-case theories and concepts, but without this hierarchized picture, it would be somehow ad hoc to distinguish fundamental or essential concepts as constituent of laws as constituent of the concepts of unknown. So the idea is that this net-like structure makes at least or motivates the different role of different laws for the constitution of the concept. So if the concept is going to be the same along the theory's change, not all laws can be constitutive, and this hierarchized structure makes room for distinguishing some of them. Let's say that at least the chosen laws must belong to the top part, which is not going to change, otherwise we are into trouble. Very likely, the top guiding principle is one of the constituents. For instance, probably nobody is using classical concept of mass if he or she denies or resigns from Newton's second law. But in many occasions, maybe not only this guiding principle, because in order to face Peacock's challenge, maybe the guiding principle is not individuative enough. But still, this has to be solved case by case, and for instance, in the classical mechanic case, which I worked a little bit in that paper, I argue that something more than Newton's second law is constitutive. If somebody comes to tell you, I know how to solve the problem of Mercury, you know, masses do not attract each other. Are you talking, are we understanding each other? So probably not. The idea is that masses attract to each other is probably constitutive, maybe because they want to unify gravitational mass and inertial mass and all that. But not, for instance, not the full gravitational law. Maybe that the square 2 is constituted. No, it cannot be, because some guys were trying different exponents and they didn't complain in the same way. They say, no, you're playing a different role. So the idea is that, yeah, we have to cut somewhere here, and this must be done this way. So the net-like structure makes plausible that different laws have different weight. That's make a different role in terms of constitution. This is the brief summary of this example. So let's go to a special philosophy of science. Another example. This I worked with a colleague from Argentina, Pablo Lorenzano, you know, and the paper that just came out in Kenya is trying to another answer to Fodor's anti-adaptationist crusade. So as many of you know, the idea, the criticism raised by Fodor is that contrary to what happens in many other decent theories like classical mechanics, etc., in natural selection, which is not decent, is indecent, there is nothing, this is the key, there is nothing which is non-truistic with counterfactual force of adaptive nature and common to different explanations in natural selection. This is his criticism, briefly put. So, the idea is yes and no. But the important thing is that the sense in which both yes and no is exactly the same as the sense we find in other highly unified theories like classical mechanics, thermodynamics, genetics, and so forth. Why yes? Well, because it is true that different particular adaptive explanations, particular explanatory models, do not have components in the explanations which are literally identical. So I'm sorry to put this, but if we pass through, we will see. For instance, in the giraffe case, we have that in certain contexts, giraffes get food supply only from tall trees. Long neck facilitates reaching tall trees. Length of the neck is transmitted with random variation to the next generation. Giraffes get energy by food supply. Energy food supply is beneficial for differential reproduction. Therefore, it follows that the proportion of long-necked giraffes increases in C. Something similar with the zebra lion case, with the speed zebras as explanandum. Black move case in Sheffield's area in the late 60s, with the explanandum being the change of the color in the Sheffield area, or the sex the sex ratio proportion. This is all we have done in the day. But the important thing is that yes, we don't have anything literally in common in all these explananda. For instance, in this zebra lion and black moose case, we have in both cases that escaping predators is beneficial for differential reproduction. But this is just because these two models are models of the specific branch of survival by escaping predators. If you have survival by energy supply, you don't have these premises in the giraffe mix. So much less if you go to other explanatory models like sex ratio models in the fecundity branch. So the idea is that there is nothing literally in common, yet there is something which could be shown as common in the following sense. In all these different explanatory models, there are some parts of these explanations which we take to be a specific specialization of the general guiding principle. Like giraffes get energy by food supply, and energy supply is beneficial for differential reproduction. Zebras escape lions by running, and escaping is good for differential reproduction. Moths escape by camouflaging, and escaping, etc., etc. The idea is that we have the moths here, the giraffes here, and both are cases of escaping predators by camouflaging or by running. So the red highlighted components of the explanations are different, let's say, bottom nomological regularities that specifies or specialize differently the same guiding principle, which you remember that you look for a function that is performed better with the trained that we have. So different natural selection explanatory models do have something in common, properly understood. Nothing literal, but properly understood. What they have in common is different specifications of the general principle, which is exactly what happens in classical mechanics. In classical mechanics, we have in the Bolton laws different versions of Newton's second law, for inclined planes, for pendula, etc. So, I conclude with a case in history of philosophy of science. 3 minutes. So, the Popper-Kuhn controversy on the rationality or rationality of normal science. All of you remember this famous passage, so he is not an falsificationist. If Karl may, I suggest legitimately treated as one. Then, oh my God, this passage is really astonishing. It is exactly the same. Although he is not a murderer. So something went wrong. Popper says that no conclusive disproof of a theory can ever be produced. Statements like this display one more parallel between circles and mind, but what we make of them could scarcely be more different. Formally view they are fundamental. For Karl, in contrast, they are an essential qualification which threatens the integrity of his basic position. Our intentions are often quite different when we say the same thing, though the lines are the same, the figures which emerge are quite different. Is Kuhn unfair? Well, maybe sometimes, but not always. Look this. Popper, the normal scientist, is a person one ought to be sorry for. He has been taught in a dogmatic spirit because he is a victim of indoctrination, and his attitude a danger to science and indeed to our civilization. So it was something that Popper was not able to articulate, to say it. So the diagnosis is that an important part of what explains the noise in this debate is the different notion of theory they had in mind. And then I also elaborated this in a paper that came out in the studies years ago. So the idea is that we have this net-like notion in mind. We can easily distinguish synchronic versus diachronic versions of theories in this modern sense. A synchronic version of theory is a particular theory net in a whole series of theory nets that constitute the whole history of the theory, which is the diachronic version of theory. So if we keep the top part preserved, we are in the same paradigm, in the same theory. We are dealing with inter-theoretic change. Then if the head changes, we have a revolution, inter-theoretic change, and then the story starts. So we have classical mechanics, but this is quite idealized, but in any case it suffices for present purposes. So the idea is that if we have this in mind, we can distinguish also between synchronic and diachronic falsifiabilism. This is falsifiabilism. Theories must logically, not pragmatically, because maybe we are interested in keep using them, but logically be abandoned when refuted, when they present anomalies. So it is ambiguous. If we accept the distinction between synchronic and diachronic notion of theories, so we have S falsifiabilism. It tells you that synchronic theories at a certain moment must logically be abandoned when anomalous. And diachronic, the whole theory extended, must logically be abandoned when its current state is anomalous. Well, synchronic falsifiabilism is true, as Popper emphasized. I thought that's insisted that you were right, but Kuhn never denied. The whole point of Kuhn anomaly story is when you have an anomaly, you have to change something. Is accepting synchronic falsifiabilism. When there is a problem, you have to do something. Yet this does not imply that diachronic falsifiabilism is true. Indeed, it's false. There are no logical reasons why you should abandon the guiding principle, the core of the paradigm. It's a matter of more procedural or pragmatic rationality that purely logical one. So Kuhn emphasizes that, and Popper, at least in certain passages, seem to deny that. And we think that with this distinction in mind, we can understand better what was going on. So just to conclude, the distinction between guiding principles and special laws is not only useful for correctly analyzing the structure of the theories and producing a bunch of doctoral dissertations, but also fruitful, at least in some cases, for a better approach to some interesting problems in other things in philosophy of science.
Yeah, so thanks for that. Instead of thinking, so I think the possibility of having this hierarchical account of theories where you have sort of different content associated with the guiding principles than with the sort of lower down principles derived from them allows for different accounts of theory change from the guiding principles versus the other components. But I think there's another possibility as opposed to saying it's just a matter of procedural or pragmatic rationality. And this is exemplified by Robert Tassal's work, where you think that the type of analysis that comes in for assessments of those guiding principles is more like conceptual analysis or something of that sort. And so when you see the transition from Newtonian mechanics to general relativity, you can see that it's driven by an assessment of the fact that you don't have a clear empirical basis for a distinction between a given motion being partly due to inertia and partly due to gravity. You've discovered that there's something empirically unfounded in that kind of distinction, and that can force you to revise your very general framework notions of Newton's second law and say that there's another force that actually doesn't make sense in this context. So that I just wanted to say that there's I think an option there that you didn't mention that I think is really
well, I actually wanted to implicitly mention that when I say that guiding principles are part of the part of what constitutes the content of the theoretical concepts. Because abandoning guiding principles is changing the concepts of the key terms of the theory. And when I say that there is nothing logical but procedural, I didn't want to mean that this procedural rationality does not involve conceptual change. By the contrary, I mean, every revolution involves conceptual change upon this framework. And the idea precisely is that in order to, I mean, we saw that we could fix Mercury's periodium to many things. Even if we were this peer and we didn't want to change classical mechanics, we can say, well, look, for Mercury, gravitation is this law, and for the other guys, gravitation is this other law. There's nothing illogical on that. There is some irrationality here, but pragmatical. But it is true, if you want to keep preserving all the planets together, you need to change your mind, literally in the sense you need to change the way in which you think about things. And this is why, when you change the guiding principle, you are reconceptualizing.
No, I don't agree.
This, I don't agree that brings it to an incommensurable problem. This is a very good
Just to what you were saying at the very end of and I wondered if you could say something about the differences or similarities of how those pictures related to Leibniz's idea. Could you speak up a bit? Sorry, I can actually hear you here. But okay. I don't really have time to start through. Do I need to repeat all that? Yeah. The very end was reminding me of Lactosius' picture of research programs, where each research program is constituted by, or partly constituted by, some very general kind of principles, but that are worked out in detail in different ways and in changing ways as a program goes ahead. And so falsification of a stage in a research program doesn't require that you leave the program, it requires that you move along. But then there are kinds of failures of programs that can make it better to change to a different program. So I just wanted to wonder.
I mean, you're totally right, actually. In our places where we especially refer to that, we mentioned Lakatos. The idea is that, well, simply, sadly enough, Lakatos couldn't develop his proposal better, but I think that the idea was pretty similar. The idea of having the nucleus, the core, and then the protective bell. I like better Kuhn because Kuhn had this the opportunity to specify different components to distinguish the essential versus the accidental symbolic generalizations. The same with the paradigmatic examples and all that. But I think that what is common here is also shared by the Lakatosian picture, and also with the idea of post-hoc rational reconstruction, because in pre-hoc we cannot take a logical step, but post-hoc things look more rational than others, and then again we are reconstructing something that at that point is procedural of that kind. But you're right.
Yeah, thanks. This is really interesting. Just a tiny question about the Kuhn-Popper debate. I'm wondering if this you're claiming that Kuhn and Popper would agree on that the falsification of S theories is a reason to abandon them. It's actually quite right, because I mean, Kuhn, just as far as I remember, Kuhn, he would say, yes, surely you want to solve an anomaly, but if you can't, you just shelve it. I mean, so it's not a reason to give up your theory, or not even your S theory. If you can't solve the puzzle, then you wait for another day, or you might never get solved.
If you solve your puzzle, then I mean,
then you change your theory. We're right, but it's not a reason. I mean, that the problem exists. It's not a logical reason to abandon your theory. You might even your S theory, because if you can't change it, then you just move on and do something else until the anomaly.
To change it to me is to change the S theory. Right. What you don't change is the D theory. Right. Because you are changing this particular version of the theory. Right. Even when you kick out, I don't know, light, you abandon certain intended application, and then since the theory is composed both by laws and intended applications, you are changing this particular version. So S theories are like pictures on a movie. So once you shoot a movie, you are changing the pictures, and every step in this, of course, there is no logical command on the way you must change your synchronic moment in the theory. But that you have to do something, that you are logically irrational if you don't do something, this he totally agrees. In a particular moment, no? Then if he doesn't agree, why we should take care of anomalies? I mean, to take seriously an anomaly as an anomaly is to be committed yourself to try to solve it. And to try to solve it, that logically you are committed to changing something, which since S theories are frozen pictures of the evolutionary theory, just modifying an potential, whatever, is a case of changing of a synchronic moment of the theory. This is my point. And as far as I can tell, Kuhn accepted.
All my questions are still raised. Oh, it wasn't. Well then, why don't we move to have both of you come up? And there's some people already in the queue. Elliot?
No.
You okay, and Matthias, you.
Oh, yes.
Oh, for
I've written about Darwin, and some historians of science have been extremely hostile to that, in part for many reasons. But the one that I want to ask you about is that I use tools from contemporary epistemology, including probability tools, to try to understand what Darwin is doing, what kinds of arguments he's describing. And this is often regarded by historians as anachronistic because Darwin didn't have these tools in his head. He would never put things that way. So, who's right, them or me? I think this is unique. I think we often have, when philosophers of science talk about historical texts, we often do this. And as we understand anachronism, it's not anachronistic, but historians often see it very differently. So can you comment on that difference between the two subjects, the two areas?
Well, historians do that too. They often use, sociological categories. So take an emblematic in your book, the Leviathan and the Airplane. Okay? They give an account of what was going on. I'm not sure that, Boyle, if he were able to read this, he would recognize himself, as an active historian. Okay, so it's, what I would say is the following. The first is, why do you have to use this framework? Okay, this epistemological framework to understand what is going on. Okay, are there questions that you are interested in that historians are not able to answer? Okay, and then the second thing, which is really crucial, is when we use this epistemological framework, do we misrepresent what people at the time thought? Okay, that's a very crucial distinction. I think. As far as I'm concerned, it's okay to read a past episode from a contemporary perspective, using contemporary categories, to the extent that you do not misrepresent what these people thought, how they viewed the situation, and so on. Okay, so that's the crucial distinction. I'm happy with rereadings of what was going on in terms of epistemological categories, but only to the extent that this does not result in misrepresentations.
But what would the misrepresentation consist in? I mean, what the historians are thinking, look, it is a misrepresentation because Darwin didn't think of it that way.
Yeah, but
he used that language to represent the argument.
Yeah, but I mean, that's a charge that can be raised against historians who use sociology or anthropology. I mean, it's the historical actors themselves did not think about the situation in the historian's terms. So.
So, Matthias, did you have a question? John,
well, it was just not really a separate question. I just want to follow up on what Elliot said, if that's all right. I was trying to give you the finger, as they say. It seems to be obviously what man didn't need Aristotle to make him rational, right? So the point, everybody's been using logic and probability theory forever. So it really depends what sort of principles you're importing. Obviously, if you try to pretend that a historical figure had knowledge, substantive knowledge that we now have, that would be anachronistic. But it seems to me that's why I don't think there is a Lakatos trap. I mean, Lakatos overdoes it. But essentially, people have been using deductive logic, using probability theory, avoiding ad hoc hypotheses whenever they could. That's constitutive of science, as far as I can see. So there's nothing anachronistic in spelling out using our better ability. It's not really new, but it's just spelling out what probabilistic arguments, what logical arguments, what ad hocness means, and so on, better than the actual historical actors. But it's not rational reconstruction in any terrible sense that historians have got worried about. It seems to be an entirely sensible thing to do. I mean, my mother doesn't know deductive logic, but I can understand when she argues that. I can reconstruct what she argues in logical terms, and it's a completely faithful representation in a certain sense, though she wouldn't recognise it as that, obviously never having studied for logic.
I feel like it's just a small comment. I mean, the problem with Lakatos is that he often tries to improve upon what so he says, well, Bohr in 1913 he didn't think about spin. Well, so much the worse for Bohr. I mean, he could have thought about it. So it's that's nonsense.
A small comment on this debate, because the flip side of this is something it's actually not so much going to reconstruct Darwin's arguments in probability terms, but if you think of how we were brought up in philosophy, we all think there is a problem of induction in Hume, and Hume never talks about induction, okay? And we try to reconstruct and find an argument there, which is there, but what is there is something we project back more likely to Hume, after Keynes and Broad and other people thought of induction in terms of probability. So there is a sensitive issue when it comes also to the history of philosophy of science, how you go back and do proper history of philosophy of science when you try to reconstruct or understand what Descartes was doing using, Bill talked about Newton improving hypothetical deductivism, and Newton of course would say, I'm doing induction, not hypothetical deductive. So that's a very interesting question which we should collectively at some point discuss, okay, how we go back and do the history of philosophy of science. So that's a comment. And I've got a question for Jose. I thought you were spot on when it comes to the theories have a complex net-like structure. So my question was whether you think the way to understand this hierarchical structure is particularly wedded to the structuralist account, whether that's the best or the most appropriate way to reconstruct theories theoretically and have various models and things like that. Which this is what worries a lot of people in this tradition, not so much the structure but the technical apparatus by which you reconstruct the theory and do it.
I think there is nothing necessary in the technical apparatus at all, and I think the technical apparatus has done a lot of damage to us, to many other people. I mean, it's good when you think properly, when you reconstruct, doctoral dissertation is important. But in many cases, when I have met young people, just reconstructing things. What's going on here? What's the phenomenon and what's the plan? So I don't know. So this is the first thing you have to think about. And then when you come up with that, then you can plug all the machinery if needed. So for certain things it's needed. For certain other things I don't think it's needed. And for this more systemic problem, I think that with a very informal account of this approach suffices. An informal component which is shared, I would say, with many other approaches with different technicalities in each case. But it is true, once you go to a specific detail, for instance, if you want really to try to individuate which laws are constituted of the concept of the classical concept of mass, maybe then it is worth to formalize in a little better way. But if you want to do a proper reconstruction of natural selection, then you have to do things better. But the use of the formal apparatus should be proportional to the formal nature of the problem. So we shouldn't formalize everything. The main ideas, I think, they are Kuhn and Snivy.
Just a quick suggestion for a rapprochement between Jose and Matthias, because I think you're absolutely right that there's a commitment there in Kuhn to say that when you face an anomaly, we need to act in some way on paying some sort of incoherence, right? But then the question is, what action is appropriate? And obviously, if we can adjust the S theory, then that's great. We can assimilate it. But there are certainly cases in which we can't think of the right exemplar by means of which to perform the right thing. And then the question of how worrying the exemplar is just part of a larger calculus, right? And that's what Matthias was suggesting. I mean, is it so worrying that we need to change our mind about other things? Is it less worrying so that we might just set it aside for the time being and see whether we might come up with something? So, I mean, that is in Kuhn, right? So I agree with you that there's some sort of logical requirement that we act in some way, but the rational action in some cases, depending on this overall calculus, might be, let's see if we can get an exemplar tomorrow.
This is why my favorite metaphor here is just the Müller one. I mean, to go for changes within the theory or for another theory is like doing something when it's raining and you have leaks. I mean, it's totally silly that at the first leak you are just building a new house, but after all the house plenty of leaks, it's silly to keep fixing them. So there is the logical obligation of doing something, but the way you have to proceed is ruled by a different kind of rationality. And there is, of course, but you can be called irrational if you keep changing exponents. I mean, in the 21st century, for solving Mercury's period,
I wanted to raise a question about the way in which philosophical insights might guide historians. It seems to be another way of thinking about that is that any historian of science has tacit philosophical convictions. And very often we have better formulations of those convictions. So if someone has tacit verificationist convictions, even if you're a realist and you can't talk him out of that, verificationism comes in flavors, and we're very good at finding the better ones. And so it does seem to me that if you think the history of science is already a philosophical endeavor because the philosophical judgments are philosophical, having people know about a literature in which various options have been refined and pruned would already be a contribution, even if your own particular philosophical view was not something you persuaded the historian of.
I'm in full sympathy with this.
Well, let's thank both for